Okay, great. Glad to see everybody here. My name is Bruce Momjian, work for Enterprise DB. They sponsor my community work. I've been with them for 7 years and been a core team member for 16 or however long it's been since 1996. I'm here to talk to you about PG Upgrade, and that is basically an upgrade in place tool for Postgres. Frankly, upgrade in place tools are not like super exciting a lot of times, but I think this one is from a perspective of how it does what it does. This is really kind of a challenging project for me. It's sort of like if you ever seen like the James Bond movies and they have these big car chases and they go like down this road and up this road and up, he jumps over the thing and over the, usually they're running on roofs. I don't know why, but they see that a lot. And James Bond, he's on top of a roof and then jumps in a window, and that's kind of PG Upgrade. So in terms of what it does, it has a challenge to do with a particular thing, and the question is, how do we make that happen? And that's really what this talk is about. Now, in terms of upgrades, effectively there are two traditional ways of doing major version upgrades. Now, this is not a minor upgrade. So if you're going from 9.2.1 to 9.2.2, that's a minor upgrade. All you do is you shut your server down, you install the new binaries, you restart your server. How long does that take? Probably 15 seconds, right? So minor upgrades that Postgres is putting out every month or every 2 months are not something that you need PG Upgrade for, okay? So the idea of fixing patches and fixing fixed releases or minor releases for Postgres, you don't need PG Upgrade, you don't need to dump restore, you don't need to do any of these big things. You just basically shut the server down, install the binaries, and restart it. Simple, okay? So most people aren't happy with just minor upgrades because, as you know, Postgres is being improved very quickly. I'm going to stay away from that speaker. Postgres is being improved very quickly. In fact, probably one of the fastest improving databases in the world, open source and closed source, in terms of what it does, in terms of the feature set that comes every year. In fact, one of the funniest complaints I get is basically people telling us to stop adding features so quickly because they can't help themselves from upgrading. I don't know how many of you have had this experience. I have any hands? Sort of like you feel that new release of Postgres comes out, you just installed it like 4 months ago, and you're thinking, I really don't need the major upgrade. I don't need these features. And you look at the release notes and you're like, oh, I could really use those range types. Oh, I could really use cascading streaming replication. Or, the JSON type. And you've got this sort of siren song of features that sort of entice you to upgrade. So a lot of people I know on traditional databases, they install a database, they just keep it. They don't upgrade. They do minor upgrades, but the idea of bringing in new features to the database is something that they do maybe every 4 years or 5 years. And you can do that with Postgres. But normally when you think of a normal database, the number of features between different major versions of a typical commercial database are not that large. 4-year span, okay, you've got some significant changes in a 4-year span for a commercial database, but maybe not, a whole lot compelling for a 1 or 2 year period. Postgres is kind of not that way. There's compelling things, frankly, almost every major release, which is every year, and that has sort of driven the need for doing these upgrades. Now, traditional way you do it, and you sort of cringe to hear it, dump all the data out, install the new major version of Postgres, load all the new data back in, okay? That doesn't really sound appealing to anyone, particularly as your databases start to grow. So as you start to get larger and larger databases, terabytes of data, of course, these dump and restores can take days. I don't know about weeks, but it's a long time, and certainly much more time than you want to take in having your server offline while all this data gets dumped and all this data gets loaded in, okay? So that's the traditional way that we had done upgrades, I would say up until about 2007 or 2008 maybe. The second way has always been available. It's called Sloaney. It's effectively a replication system, and it does allow you to do upgrades pretty much instantaneously within like I don't know, a couple minutes in terms of switching from one machine to another. But it requires you to run the old server and the new server together. It takes a lot of time to sort of get the new master kind of up, or the new version kind of loaded, and then you've got to have triggers on everything, and eventually you kind of switch over. But that is not a trivial process. Yes, sir? Not a trivial thing. You have to install a new piece of software. If you've got DDL changes, they have to go through a Sloanic daemon to get propagated. So there's all this sort of overhead of bringing in sort of a replication, trigger-based replication system just to do major upgrades, okay? But again, if that's all you got and you can't afford the downtime of a dump and reload, up until PG upgrade, you didn't really have a choice, okay? So effectively, I mean, let me give you a little like background. So, yeah, this is the method we had. Again, traditionally, Postgres has regularly changed a lot of things in major upgrades, and that has caused kind of a problem for any kind of optimization in this area. But fortunately, I would say starting about 2006, Postgres started to stabilize in terms of how it stored its data and so forth, and that really opened the door to an optimization, okay? So effectively, when you look at current Postgres, and when you look at what changes from one major release to another, what really typically changes is the system tables. So when you add, you know, materialized views, which I think we were adding in 9.3, or you add foreign data wrappers, or almost any of these features coming in, they're going to require some changes to the system tables. They might have a new syntax. There's going to be sort of this sort of new feature creep as you bring stuff in, okay? What doesn't typically change in major versions of Postgres is actually the bulk of the data. So the user data, okay, which would be your heap table, which stores your data, and your indexes, those files don't normally change. Okay, and those, for a typical database, those files are 99 or 98% of your database is your user data. Your system tables, have you ever looked at your system tables? They're like tiny. You know, maybe it's, I don't know, 50K or 500K. I mean, you just don't have a lot of data as metadata that you're storing. It's mostly your data and your indexes that are taking up most of your space. So I kind of realized a long time ago that if we could split these apart, we could do an upgrade much quicker than the traditional dump and reload here. And in fact, I realized that, I believe it's 1997, which was probably a year after I was in with Postgres, I realized that we could split apart these two ideas. And if we could upgrade the system tables without changing and preserve the data files, we would be able to do an upgrade in place very rapidly. So I wrote a shell script called PG Upgrade. And again, this is the 97, 1998 period. And the shell script worked really well. We had a bunch of people using it. But we then kind of, starting in 2000, got into a period where our data files were changing all the time. So every major release was changing the format, the on-disk format of our data, and the on-disk format of our indexes. And every time those major changes happened, it was not possible to split these apart anymore, because you had to dump your data out and reload it into the new data format that Postgres was using, either to support something like save points or something like write-ahead logging, which we didn't have in 1999. So again, we entered a period where Postgres was developing so fast, the internals were changing so fast, we couldn't separate these out. But what happened about 2006, 2007, Postgres's internal format started to stabilize. You weren't seeing as many changes. We had done a lot of optimizations in the storage format up until that point. So you weren't seeing as many changes in the data format storage in that time period. In addition, you had a lot of people using a lot of really big databases. So the size of the database was starting to get bigger. Again, 500 meg database, not a huge problem to do a dump and reload, okay? But as you get into terabytes, that dump and reload then becomes this very, very onerous process. So my employer, Enterprise DB, basically knew that they had too many customers who had these huge databases, and they needed to sort of develop a tool that used this system that I had developed a long time ago to kind of do upgrades in place. And they wrote a tool in C, not in shell script, so again, it was sort of much more reliable. But they really couldn't kind of get it polished because, again, community was developing stuff over here. They were developing an upgrade tool over here. Jim Momjian talked earlier about Postgres XC and some of the challenges they had in keeping in doing sort of parallel development with the community, and that's just not a great thing. And an upgrade tool is hard enough rather than trying to figure out how to do it on top of the community project. So my employer, Enterprise DB, came to me and they said, you know, we wrote this tool. It doesn't have any traction. We're not really able to finalize it and get it production ready. We want you to take it. We're going to BSD license it, just like the Postgres code, and we're going to contribute it to the community, and we want you to shepherd it and get it to be a production-ready tool within the community. So I'm like, okay. I think that was 2009. And the result, effectively, after about 6 months or 9 months of pretty heavy hacking on the code that they give, is basically PG Upgrade. Okay? So PG Upgrade, originally it was called PG Migrator, but nobody really cares anymore. Basically what PG Upgrade does is it gives us some very fast upgrades, and it optionally allows us to do it with no additional disk space requirements. And that's pretty good. And as John Erdman said, it's really fast. So 2 terabytes of data, or 5 terabytes, how long big was it? And it took how long? Thank you, 2 minutes and 10 seconds, right. So all of a sudden, instead of, that whole sort of rigmarole of dump and reload, or that whole problem with doing, some type of Sloaney setup, you got times down that are, pretty astronomical, and I'm going to show you later, we've even made more improvements since you used the tool, John, so I'd be interested to see what you get if in 9.3 if somebody uses it. Yeah. Yeah, that's a great example. So originally, the loan disk solution was 2.5 or a week and a half, and now it's 2 minutes. So again, if you can get this thing to work, it works really good. When I originally developed the tool, I had a lot of opposition. Community members felt that it would never work. It was too fragile. They'd never trust it was the term. One of the Enterprise DB staff said it was practically useless. But you just keep going with this thing. Jim, I think you were in the room. Although, you have to qualify it. The reason he'd used the term was related to the integer timestamp, and he was kind of right for that narrow case. But again, you got to look forward. You got to sort of see the potential there. Of course, I knew there was always the potential to do, sub-minute upgrades of terabytes of data. You just need to prove it. So you work basically within a year, 2 year time frame, sort of polishing it, getting people to try it, working on bugs, and then polishing it more, getting it easier to debug, and then getting it faster. And you'll kind of see the solution at the end there. So how does this thing actually do what it does? And again, we're back to the process of splitting up the database into 2 views. There's the system table view, which you can see in yellow here, which basically indicates all of the system tables, and that's the part that changes a lot in your major upgrades. Okay, so but unfortunately, that's a very small part of your database. And the blue part at the bottom is basically your data. That's your heap, that's your tables, and that's your indexes. Okay. So is it possible to effectively create a new copy of the system tables while preserving all of your data files, which is the majority of your disk size? And the answer is yes, it certainly is. So the first thing we do here is we have obviously a PG class, which I'm using just as a sample of one of the system tables, and it points to a whole bunch of other system tables which are up here. and it also points down here to a bunch of the data files. Okay. In addition, we have something called C-log, and C-log is our status of committed transactions. So when you commit a transaction, every time you commit, we will write a bit, or it's actually 2 bits, into C-log. And if we abort a transaction, again, we'll mark it as aborted in some cleanup operation. Okay? So those are the 3 areas we're looking at: the C-log, the data tables in blue, and the system tables. So the first thing it does is issue a freeze. And what a freeze does is it basically takes, you basically have your old cluster, which is currently running, and that's good. But you basically have a new cluster that you've got to create. And this is the new version of Postgres here. So if this is 9.2, this is 9.3. If this is 9.1, this is 9.2. Whatever, whatever you want to understand. This is the new version. So you basically create an empty database and you freeze it. And what happens when you freeze something is you basically remove any linkage from the tables up here to your transaction status log. And if you've ever seen vacuum freeze, it's something that happens every 200 million transactions that effectively marks your transactions as committed or aborted, and it basically separates the linkage here between your system tables and your transaction log. Okay, and that's going to be important because eventually we're going to move this transaction log over here because all of these tables actually reference that transaction log. So that's actually what we're doing here. We've frozen these rows, so none of these rows anymore refer to the old copy, or basically the copy of the new transaction log. So effectively what we do here is, because there's no linkage anymore, because none of these rows are looking here, we can basically take the transaction status log and the control data from the old cluster and copy it over to the new cluster. Okay? And again, the reason for that is a lot of our user data is actually accessing or needs to access that transaction status log. And we do not want to freeze all of these rows because it would take forever. So we basically just copy the rows over to the new server. And then what we do is we get a schema-only dump of the old cluster. So we basically go and we say, tell me everything about your system tables in the old cluster. That's actually the command we run to basically dump out every object, all the object information, every table definition, every function definition, every table space definition, every operator, everything about the database stored in the system tables, fortunately, is encapsulated in a text file we can create called PG with pgdumpall-schema. And once we do that, once we have the file, we can actually load it into the new cluster. So what this is effectively doing is it's now creating a modified, brand new feature-filled version of the system tables that is exactly the same, or it contains the same type of information as the old cluster. Okay? So this is basically out, and then this is basically, again, in and created. Okay? And we have a whole bunch of files down here that got created when we did that, but every one of those files is empty. They're all 0 files. Because we said create table. When you create table, you create an empty file. So there's nothing in them. And we're going to throw them away anyway, so we don't care. Okay? So the real magic is here. Okay? What we've done, just to back up here, is we frozen the system tables here so they don't reference the C-log anymore. We copied the C-log over because all this stuff's going to reference it. We basically dump out the schema and we recreate the system tables in the new cluster, and then we effectively can copy or link each file from the old cluster to the new cluster. So sometimes the numbers are the same. In this case, they all happen to be the same, but the numbers could be different at the same time. Okay? There are actually 2 modes in Postgres and PG Upgrade. You can either copy the files or you can use hard links. And the way you upgrade 1.5 terabytes of data is hard links. I don't know how many of you have dealt with Linux file system or Unix file system. Hard link allows 2 directory entries to point to the same file. Okay? So you effectively, at this case, if you use link mode, you get this file, this directory entry, and this directory entry. Even though they're in different data directories, they're pointing to the same physical file. It's very quick. Okay? The only difference is you look at the link count, and the link count is now 2 instead of 1. Okay? And that's all you do. That's it. Okay? You now have a new cluster which has data files that are exactly the same as the data files in the old system. If you use link mode, they're physically the same file. They're just 2 different entries. And we've got system tables that actually match and all of the system tables here point to the proper physical files in the database. Okay? Any questions before we kind of go on? Because I know it's kind of crazy, and you can see why a lot of people were like, yeah, I don't know about this. Yes, sir. What happens to the old cluster? So, 2 things can happen to the old cluster. If we use link mode here, okay, then once we start this new cluster, it's going to be writing to the same physical files that we have in the old cluster. We can't use this anymore. So I will actually give you a script when PG upgrade finishes, and the script, you run that script and it will delete your old cluster. So that effectively is dead. Well, it's there, but you can't start it because the files are being modified by a new version of Postgres versus the old version. Now, if you use copy mode, which is what people in testing will normally use copy mode. They won't use link mode. But in copy mode, we're going to copy every file over, and in copy mode, the old cluster and the new cluster work just fine, right? So you could run them parallel. So people who are testing are normally using copy mode. They're testing, so they don't care how long it takes, okay? They're going to do this on a standby probably. They'll make a standby. They'll bring it up to master. They'll run this in copy mode, and then they'll actually connect to both of them and run a test and see if they get to validate the whole thing. Yeah, and I do see that often. But most people then, when they finally actually do it, are going to use link mode because that's going to happen in a minute or 2 minutes, and then they've already tested it, and then they're just going to blow away the old one. The only real storage in the old one is the system tables. These files are really just dead links to something that I don't really need anymore. Yeah. This also works in Windows. So Windows has something called junction points. Who knew? But they do. You actually have trouble accessing them from the command line, but the Windows API gives you this junction point API, and then you actually create hard links in Windows just like Unix. Any other questions? I'm sorry. Okay. So let's go over a little more detail of how this works. PG Upgrade is very paranoid, so it basically gets very concerned and makes sure everything is exactly the way it wants it to be. So it basically does a whole bunch of checking. It checks to make sure that you're using the same CPU type, the same alignment. You can't go, for example, from a 32-bit binary to a 64-bit binary with PG Upgrade. It doesn't work because the alignment of the data storage is different on a 32-bit CPU binary and a 64 CPU binary. Does that make sense to everybody? Now, keep in mind it really isn't related to the CPU technically, because you can run 32-bit binary mode binaries and 64-bit binaries on the same physical CPU. Okay, but when you download Postgres, typically you're going to choose 64-bit binaries or 32-bit binaries, and you have to use the same alignment, the same type of binary width in both clusters. Yes. So is there an upgrade path to go from 32 to 64? Unfortunately, the upgrade path to do that you're back to these bad boys. And the reason that is happening is because PG dump, as I said in parentheses, it creates a logical dump. So it's not really, it's not saving the alignment, really when you dump it, it's the physical data. Sloaney has always had a major version independent API because the triggers that Sloaney creates are actually like physical copy lines, like they look like text strings. So pgdump and Sloaney, I would say, are designed to be major version agnostic, okay? And that, I have had complaints about this. In fact, I had complaints to the point where if you tried to go from 32 to 64, you would get kind of cryptic error. It would say unmatched alignment values, right? And I realized that that's not really a good API because, yeah, the alignment values are mismatched, but effectively what we're telling you is that you're going probably from 32-bit to 64 or the other way around. So I believe 9.2 or 9.3 actually says, this might be because you're actually changing your alignment for your binaries. And it is somewhat of a problem. There's just no other way to do it. Because as soon as you open the door to requiring an alignment change or even touching the files, like just anything that's going to have to actually look in that file, you're done. PG Upgrade is out of business, right? So you're not going to get, minute, 2-minute upgrades for terabytes of data if we have to do anything to it. In fact, when we actually, PG Upgrade never modified the old cluster, ever. And the design there is that if it fails, you always know your old cluster is fine because we never write to it. We never do anything to it. And in fact, when we even copy the files over, we still never do anything to it. So you can run an upgrade in link mode, and as long as you don't start the new cluster, you can just blow away the new cluster and start the old cluster. Okay? It's only the physical starting of the new server with linked data files that causes the old cluster to be invalid. Anything else, that old cluster is exactly the way it needs to be. So the idea of we've talked about maybe someday we're going to need some type of page format change, and then PG Upgrade's going to have to read the pages as it copies them and then maybe realign them or something like that. We have talked about that. I don't know when that will happen. It may happen someday. But I would basically say that the changing from 32-bit to 64-bit, which is what most people want to do, those additional alignment requirements for 64-bit binaries is probably not ever going to be something that we can, because the data is not going to fit on the page that it used to fit on because they have bigger alignment. And frankly, it's sort of a symptom of the way, and I have another talk I'm not giving today related to shared memory and how Postgres actually accesses the data rows. But it's actually on my website, which happens to be right here. If you ever want to look at this presentation or any others, it's just put my name in Google. It's pretty close. Just get it close, and it'll find it. And there's probably 30 presentations on that website, all PDFs, all Creative Commons licensed. So I actually give a lot of these talks, and other people give my talks, so it's kind of fun. And I give Josh Berkus' talks, because the talk he gave with the car I gave at 2 different locations, and it was great, and I gave him credit, and because it's hard to develop like a specific major version specific talk, like, it's good for like 6 months, and then nobody wants to hear about it anymore. So, yeah, John. Yeah, so more likely. Let me finish his question, and I'm going to talk about that, because I think you're absolutely right, and I have a later slide that actually talks about that, but I'm going to talk about that. So in terms of going from 32 to 64-bit, one of the ways Postgres accesses data files, which again is kind of, I got time. I will pull up the slide for you. Oh my goodness, okay, so you're bothering me here. So I have one slide that, here it is. Okay, oops. So the way Postgres, let me see, hold on. I'm trying to find the good slide here. Where is it? I'm sorry, hold on. It must be earlier, I'm sorry. So basically the way Postgres kind of does what it does when it just stores its data is every row basically is made up of a header and a bunch of different values. Very, very traditional. Looks just like it does when you do a select star, okay? So these are your columns that are part of this data. And there's a whole bunch of detailed junk that we have down here. But what really kind of sticks out, I think, is that when Postgres is going to read an integer from the database, okay, it's effectively reading what it thinks is an integer pointer stored actually in shared memory. So unlike some other databases which effectively will kind of store the data in some sort of canonical format that's the same on every CPU and stuff like that, Postgres effectively says, how long do you think an integer is? That's what I'm going to store, okay? How long is a character pointer? Okay, that's what I'm going to store there. So the problem with going from 32 to 64-bit is that the alignment of some of these values changes depending on, like, if you have a single byte and then you want an int8, where there's going to be some padding the CPU needs, and that padding size is going to change. The reason we do it that way is effectively if we did some type of translation, then we would have to basically incur that translation overhead every time we went to read it. So when you actually look at Postgres code and you sort of look at how it kind of accesses the data, effectively it just kind of goes in and it just pulls it out as though it's looking at a C pointer. So for example, if I'm looking for an integer, I just take a value and I cast it to integer and I'm like, that's an integer. So it's really storing the data at the native format that the CPU anticipates. Now that's not true for like a numeric, which is, you know, base 100 or whatever, but for integers and mostly text strings and stuff like that, it's pretty much reading it as the way the CPU wants to read it, including the alignment requirements the CPU wants. And that's why effectively Postgres is very fast. That's why you can't go from 32 to 64 to 32 with the binary upgrade. Now back to John's question in terms of what we were eventually going to do, you're right. I think the idea of changing data pages on the fly as we do PG upgrade is probably never going to happen. What's more likely is we will have some type of compatibility code in Postgres that will be able to read the old page format with the old whatever it is that we expected, and then have some sort of way of writing out just new data formats. So that would be a likely, when we get to a point where Postgres wants to change the data format, then that would likely be the way we would handle it. We are actually kind of brushing up against a little bit of that in 9.3, where we're thinking of adding checksums, but we don't want to assume checksums are there because we assume people doing binary upgrades are going to bring in pages that don't have a checksum up there. So how do we put a checksum in a place optionally, not knowing it's going to have a checksum? So that's kind of an example of the type of thing that he's getting at, where we would be kind of more flexible about what formats that Postgres understands, and therefore we don't have to, we can kind of, we can, there we go. So effectively we can do it a lot better. Come on. Oh my goodness, I'm sorry. Yes, this is the super excitement of presenting. There we go. I don't know why that's there. That's kind of weird. Okay. And you are there because you want to be annoying. All right, so I will close this one out. There we go. So, other questions? Okay, so let's actually walk through what it's doing. So it's going to do a lot of checking. Then it's going to dump out the old schema. We talked about that. Then it's going to freeze the rows so there's no connection between the old cluster and new cluster. It's going to actually copy the OID counter or the transaction ID counter over from the old server. It's going to copy over the C log. Then it's going to create sort of the dummy databases. It's going to install some support functions. It's going to create the new schema, and then it's going to move the data files over either as copy and link mode. And this is actually what it looks like when you run. So here we have kind of it going through, checking a whole bunch of stuff here. A lot of these checks are for very old versions of Postgres, like 8.3 and 8.4. Fortunately, they aren't things that we have to worry about. for new servers, so a lot of these restrictions aren't there anymore. Then we perform the upgrade, we run an analyze, we freeze the rows, we delete the C log, we copy the old C log over to the new one, set the transaction counter, reset the write-ahead logs, create the databases, add support functions. Down here we're linking the old and new tables together, so that's where we actually move the data files. And then we're done. And we provide a script, which has already been referenced earlier today, that analyzes the new cluster so you get optimized statistics. And we also provide a script that allows you to delete the old cluster because you probably don't want it anymore. Yes, sir. Okay, so the question is, he actually upgrades the analyzed statistics for certain tables to be 1,000, and the question is, will that get preserved? Okay, I assume, right? So effectively, anything that PG dump all would preserve is also going to be preserved by this method. So those actually are preserved. So you actually would get your 1,000. The ones that you would set, if you actually look at a PG dump all output, you would see alter table set, target, what is it, target, analyze target, something like that. Anybody remember, what's the bucket, what's the variable name? Statistics target, yeah, set the statistics target equal 1,000. And you'll see that in the, PG dump output. And effectively, PG upgrade has no idea what it's doing. It's just taking when it's basically creating creating databases, restoring database schema to the new cluster. That's where all those things are coming in from PG dump all, and they're being set up. There's no data there at that point. That's okay, because right down here we're going to start linking the data in and bringing the data over. One of the interesting aspects, and this is sort of some of the stuff we've dealt with in terms of improvements, is that when people finish their upgrade, they have no optimizer statistics. And it tells you that right there, okay? And the reason they don't have any optimizer statistics is that effectively, like the system tables, the optimizer statistics are regularly improved. So therefore, if we migrated your old statistics and your new statistics, you wouldn't get the additional value of the new statistics. So we give you a script which will analyze the statistics. And we had a discussion when Josh Drake was here this morning saying, well, how long did it take you to do the upgrade? And then the question was, how long did it take you to do the upgrade and get statistics on it, right? So in 9.2, this script is actually much smarter. It will basically run analyze with one statistics target bucket. And you'll get like bare bone, what is the most common value in that table statistics, very fast for the whole cluster. Then it'll run 10, and it'll find the 10 most common values. Again, that might take a couple minutes. And then the third thing it'll do, it'll run the default, which could be 100, which is the default for most people, or it could be 1,000 if you set 1,000. Okay? So the idea of this script, and there's quite a bit of smarts in there, is to effectively get you minimal statistics very quickly so you can get up and running, okay, and then crank up the statistics to get you full statistics as long as that takes. And again, statistics doesn't take that long, but it could take an hour or 90 minutes to get full statistics, particularly if you do 1,000 bucket, it might take even longer, okay? But again, the goal there is to be very agnostic, to allow people to change statistics very easily without kind of getting all, kind of crazy. And you can kind of get crazy with this stuff. We've had a couple people who were interested in doing this. I don't remember if any of you were around. Some of you were around when we were talking about it as a community. And the traditional way that commercial databases do these type of upgrades is that every time somebody changes something that would affect the upgrade, they have to write a little like script that would basically do the fix for them. Okay? So if you change A to B in the database storage, that person who changed A to B has to write a script that would be run by the user or be run by some kind of tool, which is going to go around the database and change A to B. Okay? And that might work if you only make 5 changes to the whole database. But as I said before, Postgres is advancing so quickly that the idea that an upgrade tool would be reliable, okay, and would allow you to kind of run, thousands of new features, or hundreds of new features that come in that release notes. And somehow we're going to write little like upgrade scripts for every one. Are you kidding me? Like I might as well stop working and just spend my time doing everything on PG Upgrade the rest of my life. I don't want to do that, okay? And I don't think I'm ever going to. The other real challenge, and it wasn't a question of time. The other real challenge is that people expect this tool to work the day you put out that new major release. Okay? You cannot be debugging it while people are using it, right? They have got to have confidence that this thing's going to work because it worked last year and it worked the year before. If you get into and this is more of a software design issue, if you get into a work process where every change ripples out to your upgrade tool, then your upgrade tool is never going to be finished. Because every time somebody changes something, your upgrade tool is going to have to be changed. And you're going to have to test that change to make sure that it's going to work. And how do you do that reliably while the code is changing and while it's got to work on day one when your users have really not been testing it yet, right? So one of the, I think, and we had somebody who wanted to basically develop that particular way of upgrading. And I was like, I don't care if that's the way other vendors do it. We do not have the manpower, and we cannot produce a quality, reliable upgrade tool using that method. So effectively, the way PG Upgrade works is it manages to take 98% of things people change in a major release and isolate them into a package that is the system tables. And because PG Dump All already has to know about the new data because the person added the feature, they've already added PG Dump All support for it, or it never would get dumped. So when you add materialized views, auto-updatable materialized views, you have to add PG Dump syntax, or nobody will ever get their materialized views out of the database. So you basically leverage the work somebody's already doing. Okay, you limit what. So the bottom line is PG Upgrade to go to upgrade 9.2 or 9.3 or 9.1. Maybe I have to change one thing in it every year. Maybe. And some of them I haven't changed. Sometimes I don't have to change anything. I think for 9.2, 9.3, I don't have to change a single thing. So the beauty in terms of design, the beauty is that the tool doesn't get changed to adjust to major versions, and therefore it just gets more reliable because you're only improving it to make it better. You're not trying to hit a moving target that's whatever major feature Postgres is going to put out next week. Okay, and that's I think that's something that a lot of people, when they originally saw PG Upgrade, did not appreciate. PG Upgrade is very paranoid about everything working the way it wants to and leveraging existing facilities that Postgres already has to dump out the schema, to copy over the C-log, to start and stop the server. All that stuff is basically standard Postgres tooling that does not change from release to release. So when you look inside of PG Upgrade, it is tremendously scary code because it is doing things at such a low level that it seems like it would be very fragile. But in fact, it's using sort of basic building blocks of Postgres and staying out of the way of most of the code churn, which is basically the system tables. So it's a very awkward tool. I mean, if you were sort of going out and saying, I want to design a tool that's pristine, that's not this tool. Because again, this tool is trying to stay out of the way of a lot of the changes and leverage a lot of the stuff that Postgres already does. And that's why this tool works really well. If you look at its adoption, again, many core members, basically, I can't trust that tool. It's never going to work right. We're never going to be able to count on it. But hey, we are 3 years later. It's listed as a standard way to do upgrades. It's mentioned in the major release notes. There's docs on it. When you go to Postgres docs, The idea of using PG Upgrade to do those upgrades is something that everybody talks about and everyone considers. They may use it, they may not use it, they may not be able to use it if you're changing CPUs. But everyone considers it. It is considered to be a solid tool. Again, very strange requirements to write a tool like this. I mean, it's not like PSQL, it's not like pgdump, it's just this sort of crazy thing that you need to do. And, you know, I've sort of been the crazy guy who will try something, and even if it doesn't make sense to someone else, you just keep at it. And if you really believe in it, you know, it a lot of times it turns out. So it's just, I think from a software development standpoint, it's a very unusual tool to work on and for people to be comfortable with. But we have definitely crossed that hump in terms of people now really relying on it. And we haven't had bugs in it for quite a while. In fact, I'm going to talk about the features we've added. So what things could make PG Upgrade not work? Well, for example, if you change the C-log format, then we're copying that C-log file over. If you change the format of the C-log file, we're in trouble because we assume that the old C-log and the new C-log are going to be the same format, same layout. I guess if somebody changes someday, we'd have to have some kind of translation tool. Because the C-log isn't that big. We could translate if we had to. Fortunately, it hasn't changed. If the page header changes or the bitmap changes, again, we would have to probably convert the new page on read or have a database that could understand both formats. We do have version numbers in the actual pages. So if we decide to go with a new page format, we can change the version number. When you read it in, you can see the old format and, you know, adjust it accordingly. If you change the heap header, the bitmap, the way data values are stored, or the indexes or the toast, again, these would all need some type of cleanup or some type of change. The good news, we haven't had to deal with it in, 3 years. I don't remember it ever being a problem. No, what John was saying, and he's correct, the way we would fix these cases is we would look at the page, PG Upgrade would run just the way it always does, okay? When you start the new server, there would be code in that new server that would say, if I am reading a page that I did not create in the new format, I will read that page and I will convert it in memory to my new format on the fly as I bring it up under the layers of Postgres. And then when I write it back, I'm going to write it back in a new format. Yeah. So you effectively catch it as it's coming in, change it to match what you need, let it go up to the upper layers, which only know about the new format, and then write it back in the new format. The downside of that is effectively you have to carry around that knowledge of the old format until forever. Until you basically say PG Upgrade can't be used for this major upgrade, which may never happen. Or you could unload it, but again, the problem is if you have 10,000 users, you would have to basically say, listen, this is not going to be the release that we're going to know. And the problem you have, and this is also some of the way that some of the vendors handle it, is they just read it in, but the problem is you start to get into a very Frankenstein situation where you're one change, fine. 2 changes, okay. When you start to look at 30 layers of changes, it's very hard to determine how those are all going to interact with each other. And you start to get these kind of things where you do a major upgrade, you don't realize it doesn't work, and then it doesn't work. And that's where you don't want to go. So we've been very lucky to not have that problem. But there is a sense that we could potentially be accumulating a lot of knowledge about old formats that might cause Postgres to be less stable. Good news is we've gone 3 years without any of them, with needing any. So hopefully, 20 years from now, what are we going to have, 5? It won't be a problem. But again, the whole reason we're able to do this is because we've made sure that our impact, there are so many changes to Postgres that do not impact us, that we dodge the bullet 99% of the time. So when somebody's developing a feature for Postgres, they almost never have to say, oh, that's going to be a problem for PG Upgrade. They can just develop it and pretend PG Upgrade is going to take care of it, because 99% of the time it does. Yeah, and that's really, again, sort of the design of the whole thing. Here's an example. This is an old example, but based 150 gig database. You can see the times going from effectively 300 minutes, which I think is, 5 hours, down to 44 seconds as you use different versions of PG dump, parallel dump, and then PG upgrade in copy mode, and then link mode. Obviously, you can see the kind of speed ups that you get. In terms of what's going on, I think this is kind of illustrative when I think of where PG upgrade is going to be, a couple years from now. You can look back and say, well, where has it been? I started work on it in the 8.4 time frame, so right before 9.0. 9.0, we added basic stability changes and stability improvements on PG upgrades, so the different configurations. Some people had some oddball configurations PG upgrade had trouble with. 9.1, we focused on performance, particularly performance for databases with many relations. Remember, I think, John, you said it took you like 2 minutes, and then Josh Drake said it took 20 minutes. Why would you have some terabyte database that takes 2 minutes, another one, which is smaller, it takes 20 minutes? In these earlier releases, the number of relations and the recreation of the schema was actually the limiting factor. You wouldn't think that create table would be a limiting factor. But if you have 1,000 or 5,000 relations, 5,000 tables, it takes some time. If you've got 20 databases that all have, 1,000 tables, it takes some time. So we had some sort of non-optimal code in there. 9.1 got rid of that. Basically, made everything almost linear scalability as you increase the number of tables. There were some inefficiencies in the older 9.0 release. 9.2, we focused on debugging because sometimes if PG dump doesn't work right or PG dump is broken, and it's not my fault. In fact, a lot of times PG upgrade will fail, and I'll be like, okay, well there, right? You see that's a PG dump error. So go talk to the people who do PG dump. That's not me. I'm just running PG dump. It's a valid database. Why should it generate an error? So then they have to go figure it out, right? Because you should never have an error in PG dump, but there are some unusual cases, and we fixed them. But again, PG upgrade was relying on that, so we made it easier to debug those type of problems. And again, better support for non-standard configuration. To conclude 9.3, I've actually worked on November, December of this past 2012. Spent a lot of time basically improving performance on PG upgrade. I actually added parallelism to PG upgrade, sort of a foretaste of the parallelism I want to add in the backend server. If anybody's been reading my blog, but effectively, I was able to get like 5x performance, 10 times performance improvements by adding parallelism. So there's some major speed ups because again, 9.2, Postgres was working great, PG upgrade was working great. Biggest complaint, it took 45 minutes. And I'm like, 45 minutes? How big is your database? They're like, 500 gigs. I'm like, something's wrong. It shouldn't take that long, right? So again, a lot of the parallelism was necessary and basically improving how quickly PG upgrade could run. People are going to see some major improvements when they start to use it. And again, we want to get that 45 minutes down to 4 minutes. For every user. I'm not going to be able to do it in every case, but the great thing is that's about it. I don't have any to-dos left really for this thing. Like performance was my last thing to really work on, and I'm hoping that effectively this will continue to be a well-regarded tool for doing in-place upgrades, for the foreseeable future. I have a couple minutes for questions, about 5. Any questions? I know we took some questions during the class. Yes, sir. Sure. Mm-hmm. So the question is, what happened to the patch that actually would allow Postgres to use less System 5 shared memory? Josh Burkus did mention that, or maybe it wasn't clear when he talked about it, but effectively, Postgres 9.3 will use something called POSIX shared memory, and therefore it will use a very small amount of shared memory just for locking. So basically, the whole requirement of updating shared max and shemall is basically gone for Postgres 9.3 and forward. Yeah. So he had mentioned that, and I remember the big shem max slides up there, but that's what he was talking about, that POSIX shared memory will now be used on all platforms. The only concern I have is that some of the BSDs are purporting slower performance for 9.3 because their POSIX shared memory is not as efficient as their System 5 was. I'm afraid that that's something those BSDs are going to have to work on. I don't think we're going to. I don't think we're going to go back to the old configuration. So that's something that's probably an open issue, but something that they're going to have to deal with. Yes, sir, John. So, okay, so could you do System 5 memory with a compile time option? I don't think it's currently available, but I don't see why we wouldn't allow that. I think certainly the people compiling it would know if their platform had that issue or not. I think there's a certain optimism that by the time 9.3 comes out, the BSDs will have addressed the issue. And I think maybe putting the configuration, I think there's a certain sense that we need to actually see a report of somebody actually seeing this slowdown and not being able to fix it before we're going to add a compile time option to do that. So I think that's really an open question of whether the final release of 9.3 is in fact going to have a compile time option. We're going to try and avoid it, but again, we need some concrete feedback from them. And right now, I'm not sure. But we didn't want to go with it by default until we had a need, if we actually had a demonstrable need for it. Other questions? Okay, thank you very much.